Hello, my name is Bogdana, and I'm a Senior Trustworthy AI Fellow at the Mozilla Foundation. And together with Professor Roel Dobbe out of Delft University of Technology, we're excited to share with you about our work investigating algorithms as social-ecological-technological systems and bringing in environmental justice perspectives on the algorithmic auditing process. A growing body of work across interdisciplinary fields has engaged with algorithmic auditing and impact assessment as a mechanism for algorithmic evaluation and accountability. Building on this work, we aim to bring in perspectives from the field of environmental justice, where scholarship and grassroots communities have been leading actors in addressing harms to marginalized communities and the environment. Their struggles span over a longer time horizon and have led to effective strategies for more comprehensive, integral, and inclusive actions in response to environmental injustice. For example, consider the water crisis in Flint, Michigan in the US, which has been recognized as the worst example of environmental injustice in recent US history. Algorithmic models have in fact been proposed to assess the risk of lead contamination of water infrastructure in individual homes and neighborhoods. To train the models, scholars have utilized voluntary residential water tests, historical records, and city infrastructure data. From an environmental justice perspective, it becomes critical to address potential sampling bias of volunteer residential testing, as well as the residents' differential access to the estimations made by the model. Low-income communities that don't have internet connection may inevitably not have access to vital data about the risks of lead contamination for their households. There are, of course, many other considerations that recent scholarships have looked at. AI systems are infrastructure, ontologically indistinct from social-ecological-technological systems. We go into that in much more depth in the next few slides. However, basically what we mean is that the AI systems are dependent on social and ecological resources to be built, used, and maintained. They also contribute to carbon and ecological costs through their dependency on computational infrastructure and their role in fossil fuel production. And furthermore, any problem that is solved through AI has underlying technical, social, and institutional components, and their interactions and infrastructures depend on and impact other socio-ecological technological systems. The SETS approach is centered on investigating the couplings or relationships between social, ecological, and technological dimensions of a system, which you see in the diagram here. Ecological justice scholar Melissa Pinadente-Pinto and her collaborators define these through these relationships or couplings. To start with, social-ecological couplings refer to human nature or social-ecological relationships, feedbacks, and interactions that impact human well-being as well as ecosystem services. Then social-technological couplings refer to the ways in which technology and human social systems interact, while ecological-technological couplings refer to the different ways in which climate and biophysical systems impact technology and vice versa, such as, for example, wildfires, which cause power outages, or rising temperatures, driving increased energy use for cooling technology in buildings. We've seen investigations of ecological-technological couplings in the context of AI systems in terms of awareness and research of the environmental impact of machine learning models and their underlying computational infrastructure. For example, Emma Struble et al. Estimate the environmental costs of large language models, while other scholars have proposed policy recommendations on how to reduce it. Initiatives like Green AI, Green Deep Learning, and online tools aim to shift existing norms in AI development by advocating for the reporting of carbon footprint alongside accuracy and other efficiency metrics in AI. We've also seen prior work on the socio-technical considerations of large language models. For example, Emily Bender et al. Call for the consideration of how risks and benefits of large language models are distributed, leveraging the literature on environmental justice and environmental racism. Furthermore, Letter Beatty and Roxana Vatapthrast discuss how cloud computing companies, and Amazon in particular, contribute to the indirect environmental harms through contracts with oil and gas industry, as well as donations to political candidates denying climate change. Lastly, we've seen much less attention in the area of socio-ecological considerations of large language models. And more broadly, scholars, including Abeba Berhain and Maria Teresa Ping, have proposed relational ethics considerations and interrogating tensions between AI governance stakeholders in the global south versus the global north. In an effort to bring in a broader set of questions in how we conceptualize, study, and measure sustainability, justice, and socio-ecological impacts of large language models and AI more broadly, our theory of change with this work is centered on the need and utility of such analysis to enable interdisciplinary collaborations in algorithmic auditing. In particular, we bring in learnings from the field of environmental justice and the just sustainabilities paradigm. The just sustainabilities paradigm highlights an equity deficit in environmental sustainability scholarship and practice, and challenges these discourses to be accountable for justice and equity. In their annual review of trends and directions in environmental justice, Julian Agman et al. Frame three central approaches in the recent environmental justice practice and scholarship. First is a focus on the practices and materiality of everyday life in the way we provide for basic human needs. For example, access to water, food, and energy, while also restructuring the unsustainable material flows that contribute to inequalities with regards to the access, security, and sovereignty to such resources on local, national, and global scales. Next, environmental justice considers spatial and cultural dimensions of impact. Major issues are related to the interdependencies between justice and identity, community, space, place, and agency, linking to critiquing the problems of gentrification, displacement, and homelessness in particular places. Lastly, key issues in environmental justice encompass the environmental degradation of ecosystems, leading to increasing vulnerabilities for the human and non-human inhabitants. Overlaying key themes in environmental justice scholarships and practice and the social-ecological-technological framework, we propose a qualitative framework of questions which could be implemented as part of an iterative algorithmic auditing process. For example, within the practice and materiality of resource flows along the life cycle of an algorithmic systems, practitioners need to consider its computational infrastructure, from mineral extractivism to data centers and infrastructures to electronic waste dumps, as well as how might the outcomes of the algorithmic model impact the way people interact with ecosystem services, for example, access to water, food, and energy. Through such lens, we call for moving away from narrow and closed-based risk approaches to impact assessments towards broad and open framings, such as participatory and then deliberative mapping. Within environmental justice, a growing number of community-led initiatives examine how environmental data about harms and injustices moves between communities and policymakers. And similarly, we call for prototyping mechanisms for reporting of algorithmic incidents, controversies, or injustices experienced by intended and unintended users of AI, and highlighting the role of workers in a growing number of calls for solidarity. What it would look like for policymakers and AI developers to enable local communities where the technology is deployed to evolve their own tools and processes for algorithmic auditing. With that provocation, we invite you to read the full paper and share with us about how this qualitative framework applies in your context. Thank you.